Dear students, good morning. In this class, we are going to discuss about regression in machine learning. And here, before we had discussed what is machine learning and what are the types of machine learning. In that supervised machine learning as well as unsupervised and reinforcement learning. So here we are going to see in detail about supervised learning, especially in that the regression problem. So in supervised learning, we have classification problem and regression problem. And classification problem under our syllabus, we are going to discuss about logistic regression, that is it is also called as a linear classifier, and SVM, that is a support vector machine non-linear classifier, and KNN, that is K nearest neighbor, it is also as a non-linear classifier. And regression, the one type we are going to see under the regression, it is linear regression. So supervised learning types, linear regression and logistic regression. We can see the difference between, that is the comparison of linear as well as logistic. And linear, the name itself we could understand, that is linear, that is when input changes the output also get changed. Likewise the logic in the sense is zeros and ones. So the similar way it predicts continuous values, the linear regressions, and logistic regressions is predicts categorical value and use best fit line, and it is use sigmoid S curve because it's a logistic. And coming to the linear regression, it solves regression problems, and logistic regression, it solves classification problems. And in detail, we are going to discuss about this linear regression. So linear regression is a type of supervised machine learning algorithm that learns from the labeled data sets. Already we have discussed what is labeled data sets. The name of that specific data is mentioned before itself, that is before feeding as an input, it will be mentioned, that is called labeling, right? The labeled data set and maps the data point with most optimized linear function, which can be used for prediction for new data sets. And it assumes that there is a linear relationship between the input and output, meaning the output changes at the constant rate as the input changes. Yeah, that's why I explained the last slide, that is whenever the input changes, the output or the variation will be happen the output also. This relationship is represented by a straight line. For example, here we have the best example. We want to predict a student exam score based on how many hours they studied. We observe that as a student study more hours, their scores goes up. If in this example of predicting exam scores based on hour studies here, so just simple example we could take, but here also based on hour and the students performance, it may get varied, but for assumption we could consider this example. And here the independent variable, that is the input is the independent variable, hour studied, because it is the factor we control or observe, that is the independent variable. And dependent variable, based upon this input, the output could vary, that is called dependent variable. That is exam score, because it depends on how many hours were studied, that is output, it is called dependent variable. And here the formula for linear regression. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variable. So as we mentioned, that is y cap equal to theta naught plus theta 1 into x. Here y cap is the predicted value of the dependent variable, that is output, and x is the input variable, right? And the example what we had here is predicting a person's salary based on years of experience. Obviously we knew if the years experience is increases, the salaries goes on increasing. So this is the best example for the linear regression. And types of linear regression, we may have the two types, that is simple linear regression, multiple linear regression. Simple linear regression predicts the dependent variable using a single independent variable. So the independent variable, it may be a single. And multiple linear regression, so here it uses two or more independent variable to predict the dependent variable, that is multiple linear regression. So types of linear regression, when there is only one independent feature, it is known as simple linear regression, or univariate, that is univariate linear regression, simple linear regression. And where there are more than one feature, it is known as multiple linear regression or multivariate regression. Multiple linear regression. Simple linear regression is used when we want to predict a target value dependent variable using only one input feature dependent variable, it assumes the straight line relationship between the two. Okay, and coming to the multiple linear regressions involve more than one independent variable and one dependent variable. The equations for multiple linear regression is y cap is equal to theta naught plus theta 1 x1 plus theta 2 x2 plus and so on, and theta n xn. This is how the multiple linear regression exists. And the real world use cases, multiple linear regressions, that is stock market prediction, real estate price prediction, medical risk prediction, and sales forecasting. These are the real time use cases of multiple linear regressions. Thank you for your passion listening.